Okay, 100 fractions. There's also going to be a video that this guy, Black Pen, Red Pen, does. And this is my video. I'm also going to post a Sage video of doing these problems over here. We'll start, kind of slow. And certainly we're going to recommend certain things. And we'll go through those recommendations as we go through the problem set. So first thing over here, I would recommend writing this as 15. And then the bottom would be 15 times 3. And this is going to be 15 over 15 times 1 over 3. And this might seem ridiculous, but 15 over 15 is 1, and 1 times 1/3 is just 1/3. All right, that one's done. Now, if I do this one over here, I'm looking at it, and I'm going to say, the top is going to be 8 times 3. We'll discuss what we're looking at when we do these problems over here, and the bottom is 8 times 5. If you look at that, you'd say, oh, it's 8 over 8 times 3 over 5. What does that give me? 3 over 5. All right, let's do the next one. And again, if I'm looking at it, I would probably say 8 times 3. And the bottom, I'd say 8 times 1. What does it give me? 8 over 8 and 3 over 1. 8 over 8 is 1, and 1 times 3 over 1 is going to be 3 over 1, and 3 divided by 1 is just 3. All right, this one over here, I'm going to do something a little bit different now. I'm going to write down 18, and then write 81 down. And I notice they're divisible by 9. So if you divide the top by 9, you would get 2. And if you divide the bottom by 9, you get 9. Some people do it this way. They do 18 over 81. They put a slash through this. They divide by 9. They get 2. They put a slash through this. They divide by 9. They get 9. And they say 2/9. Whatever works for you. Let me get my eraser out. And let me box the answer 2/9. All right, let's keep moving. And it can be a long problem set. 14 over 35. I notice there's a factor of 7 common at top and bottom. Let me write that down for you. 7 times 2. And the bottom is going to be 7 times 5. So what do? Cancel the 7s. And we're left off with 2/5. Let's do this one over here. And again, they get a little more challenging, but the bottom line, I hope you realize there's something common between top and bottom. Now, if we look at the 69, I notice there's a 23 there. 23 times 3. Now, if you look at the 57, I'm going to say it looks like a 3 again, and that's going to be 19. Let me just go through that. 3 times 19 is 30, and 3 times 9 is 27. 30 and 27 is 57. 3 times 20 is 60. 3 times 3 is 9. What cancels over here is the 3, and we're left off with 19 over 23. Every problem we've done so far, proper, that's just an integer, proper fraction, proper fraction, proper fraction. 0 over 7, how many times does 7 go into 0? 0 times. If you want to write down the long division, it would look like this over here. You'd say what multiple of 7 would give you 0? That would have to be 0, because 0 times 7 is 0. Now, if you look at the next one, people often confuse this, by the way. They say 0 goes into 7. There is no number times 0 that would give you 7. This is undefined. Can't divide by 0. That's worth remembering. You cannot divide by 0. Let's do this one over here. And kind of looking at it, again, there's a variety of ways of doing it. You can say, well, I want to start simple. I know they're both even numbers, and divide the top and the bottom by 2. And what would you get? 21, if you divide the top by 2. If you divide the bottom by 2, well, 2 goes into 56, 25, 28 times. Now, by the way, it's the same thing. It's equal to that. But now I'm starting to say, oh, gee, there's a 7 there too. 7 goes into 21 3 times, and 7 goes into 28 4 times. So 3/4. Again, a proper fraction. Let's keep moving through this. What's this one over here? 30 divided by 34. And I'm going to divide by 2. What do you get? You get 15. And at the bottom, what do you get? You get 17. Done. Let's do the next thing, which is basically almost like reduction. The only difference is what we're looking at now is we're not looking to multiply. I know it says multiply. We're really looking to reduce. And what do I notice immediately? And I'll write this down for you. I get the factors of 5 and 2 on top. On bottom, I get 6 is 2 times 3. And then you get 15, which is 3 times 5. What happens over here? 2's cancel, and the 5's cancel. We left off with, well, those slashes mean the number 1. So the top is 1 times 1, which is 1. And the bottom is 1 times 3 times 3 times 1. That's a slash, by the way, which is going to be 9. Now, granted, that might seem confusing to do it that way. Let me just do it a little differently. 5 over 6 and 2 over 15. You may just simply say I'm going to, 5 goes into 5 one time, goes into 15 3 times. So I'm not factoring. 2 goes into 2 once, and it goes into 6 3 times. We're left with 1 times 1 on top, which is 1. That's what those slashes mean. And on bottom, what do you get? You still get 9, so it's 1/9. Let's look at this over here. And looking at it, I'm going to, look at one thing at a time, which is I'm going to look at 35 and 19 on top. 19, there's not much I can do about it. It's prime. But 35, I could write as 7 times 5 and then times 19. On bottom, what I say, 38, which is 2 times 19. And then I get to 21, which is 3 times 7. 19 cancels. Let's see, 7 cancels. And let's see what I'm left with now. I'm left with 5 on top. And on bottom, I'm left with the 6. 5, 6. Let's keep moving along. This one over here, I'm noticing 15 and 45 has something in common, and that's a 3. And then the 12 and the 16 have a 4 in common. So 4 goes into 12 3 times, and it goes into 16 4 times. We're left off with, well, on top you're left with 3. On bottom you're left with 12. Oh, you know what? I'm sorry. That's going to be 1/4. And why is that? 3 cancels 3. I didn't see that. It's just simply 1/4. Let's put this one down over here. And looking at it, I'm looking at the 5s again. And 5 goes into 5 once. It goes into 25 5 times. And then looking at the 6 and 42, 6 goes into 6 once. And it goes into 42 7 times. So you're left off with 5 on top, 7 on bottom. Let's keep doing this over again. 23 over 40. Some students like to write the 8 as 8 over 1. That's fine. 8 goes in 8 once. It goes into 45 times. We're left off with 23 on top and 5 times 1 on bottom, which is 5. This is an improper fraction, and you may want to write it as a mixed number. What's it going to be? 5 goes into 23 4 times with the remainder of 3/5. And this is often confusing for students. What does it mean? It actually means 4 and 3/5. In algebra, we prefer improper fractions, though, so this would be the appropriate answer. Let's do this one over here. And again, looking at it, the first thing I notice is the 5s, all right? So let me write this down for you. I'm seeing 50. I'm going to commute the bottom and 15. Then when I see 14 over 49. So I'm going to say 50 over 15 reduces by a 5. And so 5 goes into 50 10 times, and it goes into 15 3 times. Right, I'm looking at 14 and 49. I'm going to say 7. 7 goes into 14 2 times, goes into 49 7 times. We're left off with here 20 over 21. Let's keep moving. What's the next one going to be? Well, looking at it, I'm going to say 3/12 is 1/4. 4/9 is not reducible, but I do notice the 4's cancel. I'm left off with 1/9. Let's do the next one. And I'm going to commute these things around, so 15 over 25. When I say these things are factors, I'm commuting around. And then what do you get? You get 3/14. 15 over 25 is going to be 3/5. And then you get 3/14 over here. What does that give you? 9. 3 times 3 is 9. And 5 times 14 is 50 and 20, which is going to be 70. Let's put this one down. And looking at it, there's not much I can do about that. And the reason I just look at it, I can multiply it though. 3 times 7 is 21. There's no factor common between top and bottom. And the bottom is 26. Proper fraction. Over here, some students prefer to write this as 40 over 1. If you're in that category, please do that. What I'm going to do? Well, I'm looking at it. 5 does go into 40 8 times, and 8 times 3 is 24. So I'm left with 24 over 1, which is 24. All right, let's keep moving. And again, this does take time and effort to get through. Let's write this as a multiplication problem. Although to say divide, I'm going to simplify it. So it's 8/5 times 15 over 2. What do you get there? Well, 5 goes into 15 3 times, and 2 goes in 8 4 times. And 4 times 3 is just 12. Let's do this one over here. 24 over 25 times 15 over 14. Well, again, I'm looking at it, and I'll rewrite it a little bit differently. I write it as 15 over 25 times 24, I'm commuting, over 14. I'm going to reduce it, and what do I see over here? I'm dividing by 5. This would be 3, this would be 5. And the 24 and 14 I'll divide by 2, that would be 12, that would be 7. So what do you get? 36 on top, because 3 times 12 is 36, 5 times 7 is 35. Let's do this one over here. I'm going to write the 9 as 9 over 1 times the reciprocal of 3/14, which is 14 thirds. What do I notice about this over here? 3 does go into 9 3 times, and 3 times 14 is 30, and 12, which is 42. What's this one over here? 13 fifths times 1/4. Not much I can do about that. 13 times 1 is 13. 5 times 4 is 20. It's a proper fraction. Put this one down. 9 over 35 times 14 over 45. Well, what's nice about this, 9 goes into 9 once, it goes into 45 5 times. And then I see the 14 and 35, and there's something about a 7 over there. 7 goes into 14 2 times, goes into 35. Again, we're divided by 7 5 times. We're left off with 2 on top, 5 times 5 on the bottom, which is 25. All right, let's do the next one. And what do I see there? 18 over 23 times 6 fifths. I'm sorry, not times 6 fifths. Let me get my eraser out. Gee, I'm only on the, let me get my thing back. No, I can't. Oh, it's right down here. I was wondering where it was. Let me erase this, okay? And let me get back my pen. That's 5 6. Sorry about that. 6 goes to 18 3 times. So I'm left with 3 times 5, which is 15 over 23. All right, for some students, the crossing out is confusing. For other students, crossing out is necessary. Whatever you need to do the problem, all right? Let's put the next one down, which is 27 over 28 times 48 over 18. I'm going to write this one a little differently. I'm going to write 27 as 3 times 9. I'm going to write the 28 as 7 times 4. I'm going to write the 48 as 4 times 12. I'm looking for factors that are common between top and bottom, and then 2 times 9 for the 18. Looking around, do I see things? Yeah, I do see the 9s canceling off. I do see a 4 canceling off. And someone says, do you see anything else? I do. I see a 2 going into 12 6 times. And what are you left off with over here? Well, 6 times 3 is 18. And then on the bottom you get 7. Now looking at it, it's an improper fraction. I just want to go through what it means to me. 7 goes into 18 2 times. 2 times 7 is 14. And I got a remainder of 4 7s. Right? What does that really mean? 2 and 4 7s. All right. Let's do the next one, which is 15 over 35 times 45 over 25. Now, by the way, there's an abundance of 5s in the problem. Let me just kind of do it slowly. And 15 over 35, I'm going to divide by 5. That would be 3 over 7. And 25 and 45 also have 5 in common, and that would give me 9 fifths. We're left off with 27 over 35. And I'll put a box in that. All right, let's put the next one down, which is 9 sixteenths times 64 over 81. Whoops. So I'm looking at the 9 and the 81, and that does reduce, by the way. It gives me a 9. And 16 goes into 64 4 times. We're left off with 4 ninths. All right, let's put down number 30. And what's that going to be? 10 over 21 times 7 quarters. 7 goes into 7 once, and it goes into 21 3 times. 2 goes into 4 twice, and it goes into 10 5 times. We're left off with 5 on top, 3 times 2 on bottom, which is 6. All right? All right, let's do our additions now. Same denominator. What do you get over here? You get 6 15ths. Time to reduce, and it has reduced by a factor of 3. So it's going to be 2 fifths. Let's put this one down. This is going to be 15 over 35 because 18 minus 3 is 15. These are the same denominators. Divide through by 5, you get 3, and on bottom you get 7, 3 sevens. Let's do this one over here, 16 over 42. And again, if you divide by 2, what do you get? You get 8 over 21. When I say divide by 2, the top has a factor of 2, the bottom is a factor of 2. We're basically canceling a factor of 2. What do you get over here? Well, 19 and 12 is going to be 31 over 38. Not much I can do about that. Let's put this one down. 11 twelfths minus 4 twelfths is going to be 7 twelfths. And again, there's not much I can do about that. Let's put this one down. What do you get there? You get 15 over 51. Well, looking at it, let's see, 3 times 5 on top. And on bottom, it's going to be 3 times 17. So what do you get over there? The 3's canceling. You get 5 17s. Let's keep moving along. What do you get over here? Well, you get 21 as the denominator, and 19 plus 23, let's see, that's going to be 52. What do you get there? It's reducible. Oh, no, it's not reducible. I'm sorry. 52 over 21. Let me point this out to you. 52 is 2 times 26, and the bottom is 3 times 7. And the 26, you want to do that, that's going to be 2 times 13, and that's over 3 times 7. There's nothing in common, all right? So you don't need to write that down, by the way. Now, it is an improper fraction. If you want to write it as a mixed number, be my guest. I'll do that for you. And 21 goes into 42 2 times. Let me write that down for you. 21 into 52. 2 times. 2 times 21 is 42. What's the remainder going to be? 10. So where do you get 2 and 10 divided by 21? Or you could write down 2 and 10 over 21. Now, I'm really not interested in writing down the mixed numbers, but you could do it. I'm not saying it's bad to do, but for the most part in algebra, improper fractions are preferred. Also in arithmetic, they're preferred as well, by the way. In the English language, we do prefer mixed number. Let's do this one over here. What do you get? You get 6/8. What's that? It's reducible. 2 goes into 6 3 times, and it goes into 8 4 times. What do you get over here? 25 15ths. And I'm going to reduce it. 5 goes into 25 5 times, into 15 3 times. Also, that's improper. And if you thought about it, 3 goes into 5 once with a remainder of 2. Let's do this one over here. What do you get? 20 over 60. 20 goes into 20 once, and it goes into 63 times, so 1/3. All right, these are different denominators. It becomes substantially more difficult. You need an LCD, and the LCD between 8 and 4 is going to be 8. So you can get 7 minus, well, what times 4 is 8? 2. 2 times 3 is 6. What do you get up there? 1/8. Let's keep moving along. Different denominators. Common denominator is 15. 3 times 5 is 15, so 3 times 4 is 12, and then plus 2. What does that give you? 14 15ths. What do you get over here? Common denominator of 25. And what do you get there? You get 7. And then 5 times 5 is 25, and 5 times 3 is 15. What does that give you? 22 over 25. All right, this one's a little tricky. It's 3/4 plus 7 over 1. What's the LCD? It's 4. Let me go over here, by the way. I realize I'm squeezing things in over there. What do you get there? 4. And this would be 3 plus, well, 4 times 1 is 4, and 4 times 7 is 28. So what do you get there? You get 31/4. All right, put a box in that. Again, if you want to rewrite that, you can. And someone says, what would it give you? It would give you 7 3/4. And that's exactly what they gave me, which is 7 3/4. All right, let's put the next one down. It's a subtraction problem. Getting a little better. I'm going to write 3 as 6/2 minus 5/2. What does that give you? 1/2. Put the next one down. Common denominator, I would say, is 35. Put this over here. Let's see, 7 times 2 is 14, plus 5 times 2 is 10. What do you get? 24 over 35. Put the next one down. LCD there is 24. And let's see, 3 times 8 is 24, so 3 times 3 is 9, plus, well, 8 times 3 is 24, and 8 times 2 is 16. 16 and 9 is going to be 25 over 24. All right, let's put the next one down. Looking at it, I'm going to say the LCD is 30. What times 6 is 35? 5 times 5 is 25. Then you're going to get what times 15 is 30 is 2, and 2 times 2 is 4. So what do you get? 29 over 30. Let's keep moving. What do you get over here? Well, looking at it, and again, I want to point out the LCMs, right? If you get confused, let's just write this down. One thing you write down is you could write the multiples of 10 down. It's 10, 20, 30, 40. I think you get the idea. And you could also write the multiples 18 down, 18, 36. Get the idea. Another way to do it, instead of writing multiples down, is simply factor them. And 10 is 2 times 5. And 18 is going to be 2 times 3 times 3. So the LCD needs to contain those factors. Well, I see a 2, I see a 3, and I see a 5. Now, it's the maximum of times you need them, and 3, I need 2 of those. All right, so what do you get over there? Well, you get 10 times 9, which is 90. But if we wrote the multiples down, you get to the 90, by the way. So 9 times 10 is 90, 9 times 7 is 63, minus, what times 18 is 90? Well, if you give a little thought, it's going to be 5. That would be 50 and 40, right? That gives you 90. And 5 times 5 is 25. 63 minus 25, let's see, you get 25 and 13, which is going to be 38. Let me just check myself there. 38, 48, 58, yeah, 63. I can reduce that. And what does it reduce to? Well, 2 goes into 38 19 times, and it goes into 90 45 times. All right, let's keep moving. Next one, I'm looking at 35 and 14, and let's just review that LCD business again. So I'm going to erase this over here, and I'm going to go through the LCD business again. You could write multiples down, and the multiples of 35 would be 35 and then 70. I think you get the idea. You could write the multiple of 14 down, that 28, yada, yada, yada. And you're looking for a least common multiple. But I'm going to claim over here, if you just factor 35, that's going to be 5 times 7. And if you factor 14, that's 2 times 7. Well, the LCD, or the LCM, by the way, is going to be 2 times 5 times 7. Only one 2 is needed, only one 5 is needed, and only one 7 is needed in each of those factors. What does that give you? 70. I'll write that down for you. And then what do you get? Well, what times 35 is 70 is 2, so you get 62. And then plus, and what times 14 would be 70? That would be 5. That would be 50 and 20, which is 70. 5 times 3 is 15. What do you get over here? You're going to get 77 over 70, which reduces. What do you get? 11 tenths. I'm dividing by 7, top and bottom, or canceling the factors. The factor 7 is common between top and bottom. All right, this is a mixed challenge. And remember, 0 out of 29, there's 0. There's nothing there. All right? So what do you get over here? At 6/14. 6/14. I'm going to reduce it, and that's going to be 3 7s. What's this one going to be? Well, common denominator 21. And what do you get there? Let's see, 7 times 3 is 21, so you get 35, because 7 times 5 is 35. And what times 7 is 21? 3, and 3 times 5 is 15. What do you get there? 35, 40, 50. 50 over 21. Again, it's an improper fraction, but we prefer it. What do you get over here? I'm going to say 8 divided by 1 times 5 over 2. 2 goes in 4 times. 4 times 5 is 20. Let's write this one down. LCD is 14. What do you get? 11. What times 2 is 14? 7. So you get 11 minus 7. What do you get? 4 14ths. And that reduces to 2 7s. Let's keep moving. What's the next one going to be? Well, this is 70. What do you get there? Let's see, 37 minus 19. Let's see, that's going to be 18. 18 over 70, well, I'm going to reduce it. I'm going to divide by 2, and that would give me 9 over 35. We'll put this one down, it's a multiplication problem, and it's 2/5 times 40 over 1. 5 goes into 40 8 times. 8 times 2 is 16. All right, let's put this one down. It's 2/5. Now we're dividing by 40. It's like multiplying by 1 over 40. Well, I'm looking at it, I'm gonna say the 2 cancels in top and bottom. 2 goes into 40 20 times, and 5 times 20 is 100. That's 1/100th. So the next one, it's a subtraction problem. I'm gonna write it as 10 over 1 minus 2/3. Common denominator is a 3, so I get 30, because 3 times 1 is 3, and 3 times 10 is 30, minus 2, which is 28/3. Again, it's an improper fraction, but we're going to leave it that way. What do you have here? 12 over 1 times 2 over 5. What does that give you? 24 over 5. All right, let's keep moving. What do you get over here? 2 7s times 5 over 1. That gives me 10 over 7. Again, it's an improper fraction. We just leave it that way. Looking at this one over here, again, looking at it, I'm reducing it, and maybe I should slow down a little bit. I'm going to say 8 is really 2 times 4. And 35 I'm going to say is 5 times 7. The 15 I'm going to say 3 times 5. And the 2 I'll just call it 2. The 2's cancel. What else cancels? The 5 cancels. What are you left off with? 4 times 3 on top, which is 12. On bottom, you're left with a 7. All right, let's do this one over here. Now, again, I got to get an LCD, and this is probably the worst thing about these guys over here. And let's write this down, 35, that's 5 times 7, and 28, all right, is actually 4 times 7, or 2 times 2 times 7. I'll just say 4 times 7. What's the LCD? Well, actually, it's the LCM of those numbers, but we're doing a fraction with LCD. So it's going to be, let's see, a 5, a 4, and a 7 is needed. That's going to be 140. Okay, again, 5 times 4 is 20, and 20 times 7 is 140. 35 times what's 140? Well, that would be 4, and 4 times 8 is 32. Plus, well, 28 times what number? That's 5, because 5 times 28 is 140. So you get 15, because 5 times 3 is 15. What do you get over there? 47 over 140. All right, let's do the next one. Again, it's problematic, but it might be a little bit easier. It's 33. That's the LCD, by the way. 3 times 11 is 33, and 3 times 8 is 24. Minus 7. And what do you get there? Well, you get 33 as a denominator. And let's see what you get there. You'd get 17. Let's do the next one. This is 5/12 times 6 over 1. Well, what's nice about this? 6 goes into 12 2 times, so I'm seeing 5 over 2. Let's put this one down. Common denominator is going to be 12. And what are you going to get? 5 minus, well, what times 6 is 12? 2. So it's 2 times 1. This gives me 3/12, and that reduces to 1/4. All right, let's do this one over here. It's a simple fraction. Divide top and bottom by 9. You're going to get 3. Oh, you know what? It's more than 9. It's 27. 27 goes into 27 once, and it goes into 81 3 times. So 1/3. Now, let's say you didn't see that. Let me write this down for you. 27 over 81. Let's say you simply said, oh, I'm going to divide by 9. What do you get over there? 3. The top is divided by 9. It's be 3. And what's the bottom? 9. And then you say, oh, that's divided by 3, so you get 1/3. All right? Let's do the next one. What's going to be 5/18 times 27 over 10. Well, immediately I notice the 5 goes into 5 once, it goes into 10 2 times. And then I notice there's a 9 between 27 and 18. 9 goes into 27 3 times, goes into 18 2 times. We're left off with 3, and 2 times 2 is 4, 3/4. Well, let's do this one over here. It looks pretty simple. 20 minus 7 is 13, and these are the same denominators, 39. Now, 39 contains a factor of 13 because 3 times 13 is 39, so it's going to be 1/3. Let's do this one over here. It's common denominator 8, so it's already there for me. And then I'm going to add 21 and 19, which is going to be 40. And 40 divided by 8 is just the number 5. All right, 49 over 56. All right, now looking at the 49, someone says, what are you going to do with that? I'm going to say the only thing it could be is 7 times 7. Now the 56, I'm going to do something a little unusual. I'm going to do this type of division. 2 goes into 56 28 times. And then you might say, oh, 7 goes into that 4 times. So really what you're left off with 8 times 7. What happens over here? The 7s cancel, and you get 7 ace. Always look around for something, by the way. Now I'm looking at 90 and 27. I'm going to say 9. That's going to be 10, because 9 goes into 90 10 times. And 9 goes into 27 3 times. Yes, it's an improper fraction, but in algebra, we actually prefer that. All right, let's do this one over here. A little more complicated. Let's put the 39 down. And what's that going to be? 3 times 13. And the 21, I'm going to say it's 3 times 7. So what's the LCD in this particular problem? It's going to be 3 times 13 times 7. And yeah, it's problematic. So 3 times 13 is going to be 39 times 7. And 39 times 7, I'll write this down for you. 7 times 30 is 210, and 7 times 9 is 63. So the LCD here, it sounds outrageous, right, is 273. All right? Now, what times 39 would give you that number? It's going to be 7. So 7 times 1 is 7. Now, I want to point out what times 21, this is 21, by the way, would give you that number. It's 13. And what's 13 times 2 is 26. 7 and 26 is going to be 33 over 273. All right? So I'm going to say I'm done there. Make sure of that. Yeah, 273 has a factor. Oh, you know what? There's a factor of 3. I should say I'm done. 3 goes into 33 11 times. And 3 goes into 273 7 times 13, which is 70 and 21, 91 times. I'm sorry, I just misspoke. I think I did. The 3 canceled. I'm left with 13 times 7, which is going to be 70 and 21, 91. Let's do the next one. It's 5/12 times 1/15. 5 goes into 15 3 times, so we're left off with 1, and 3 times 12 is 36. Let's put this down. It's going to be 8 over 1 times 5 over 6. I'm going to reduce it, and I'm going to reduce it by a factor of 2. 2 goes into 8 4 times, and it goes into 6 3 times. What are you left off with? 20 thirds. All right, let's keep going. And I'm kind of running out of room over here, so I'm going to put this over here. It's going to be 8 over 1 minus 5 over 6. LCD is 6. 6 times 1 is 6. 6 times 8 is 48. 48 minus 5 is going to be 43 over 6. It's an improper fraction, but it's fine to say that. What's over here? Common average is going to be 10. Let's see, 5 times 2 is 10, so you get 25, because 5 times 5 is 25. 2 times 5 is 10. 2 times 2 is 4. So what do you get? 29 tenths. Let's put this one down. It's 18 over 49 times 14 over 3. Well, I'm kind of seeing it. 3 goes into 18 6 times. And I see a 7 now. This is going to be 2. And 7 goes into 49 7 times. So we're left off with 6 times 2 on top, which is 12. On bottom, you're just left with a 7. Yes, it's improper, but we're going to leave it that way. 28 divided by 0 is undefined. And let's put this down. It's going to be 45. 5 times 9 is 45, and 5 times 1 is 5. 9 times 5 is 45, and 9 times 1 is 9. 9 plus 5 is 14, and you get 14 over 45. Those two have no factors in common. All right, let's do this one over here. And again, more challenging. I can see 45 and 36. I can write the 45 down. The factors of 45 are going to be 3 times 3 times 5. 3 times 3 is 9, and 9 times 5 is 45. And 36 is going to be 3 times 3 times 2 times 2, which is 9 times 4, which is 36. What's the LCD? Well, it's going to be, I need 2 3s, that's a 9. I need 2 2s, which is a 4, and I need a 5. And 4 times 5 is 20, and 9 times 20 is 180. So the LCD is 180. All right, 45 times what is 180? 4 times. 4 times 2 is 8. What times 36 is 180? Is 5. Again, 5 times 36 is 150, and 30, 180, so 5. 5 times 5 is 25. We're left off with 33 over 180. I'm going to say it looks like it goes by 3. 3 goes into 33 11 times, and 3 goes into 180 60 times. So 11 over 60. All right, let's keep moving. We're getting close to the end now. Again, common denominator, let's put this down for you. 35 and 15. Let me write it down for you. 35, that's going to be 5 times 7. And 15 is 5 times 3. What's the LCD? Well, I need a 5, I need a 3, I need a 7. And what's that going to give you? Well, 5 times 3 is 15, and 15 times 7 is going to be 70 and 21. So it's 91. I think I made a mistake there. It couldn't be 91. Let me get my eraser out. So 35 is 5 times 7, and 15 is 5 times 3. And so it's going to be 5, 3, and a 7. And 15, I made a mistake there. Sorry about that. 5 times 3 is 15 times 7. And I made a mistake by saying something that's not true. 5 times 10 is 70, and 5 times 7, I said 21. It's not 21. It's 35, so it's 105. All right? So it's important you look back over and say, that's not possible, and you do it again. 105. 35 times what is 105? 3, and 3 times 3 is 9. Now, 15 times what is 7? It would be 105. And then 7 times 13 is going to be 70 and 21, which is 91. What do you get? 100 over 105. And I'm going to divide through by, 5. What are you going to get? 20 over 21. All right? Let's do this one over here. Again, it's more challenging. And I'm looking at this thing, an LCD again. Let me get my eraser out. Done with this. You don't need to show your work on an LCD, by the way. 24. Well, I'm going to write as 8 times 3. And the reason I'm doing that is I see 40 as 8 times 5. So what's the LCD going to be? 8 times 15. What's that going to be? 80 and 40, which is 120. Okay, what times 24 would be the 120, and that's going to be 5. But this 5 times 1 is 5. What times 40 would be 120 is 3, so I'll put 3 down. What does that give you? That gives you 2 over 120, and that reduces to 1 over 60. All right, let's put this one down. A little more, this is easier for me, it's 30. And what do you get? 6 times 5 is 30, so 6 times 2 is 12. And then plus, well, 5 times 6 is 30, so it's going to be 5 times 1, which is 5. That's 17 over 30. All right? This is undefined. You can't divide by 0. You can try, but it's not going to happen. What do you get over here? 16, because 11 and 5 is 16 over 18. This reduces, and what do you get there? Well, 2 goes into 16 8 times, and it goes into 18 9 times. All right, 35 and 45. Boy, it's like deja vu all over again. Like a lot of things, write them down. So what do you have here? 45. I'm going to say 3 times 3 times 5. 3 times 3 is 9, and 9 times 5 is 45. And if you look at 35, right, what are you going to get? 5 times 7. All right? So what do? LCD. You need 2 3s, which is a 9. You need 1 5, and you need a 7. So what do you get there? Boy, it's not a nice number, is it? So, there are many ways to do it. I'm going to say the way I would probably do it is I'm going to do 9 times 35, because 5 times 7 is 35. What does that give you? Well, 9 times 30 is 210, and 9 times 5 is 45. So what do you get? 255. Let me write that down for you. 255. Now, granted, I know it's difficult looking at it, but 7 times 45 is 255, because that would be, let me make sure I said that right. 7 times 45. I made a mistake somewhere. I just noticed it. 45 is 3 times 3 times 5. 35 is 5 times 7. And the LCD is going to be 9 times 5 times 7. 9 times 5, 9 times 5 times 7. 5 times 7 is 35. 9 times 35, I just made that mistake, and I just see it again. And someone says, how do you know you made a mistake? I couldn't get 255 from 45. Didn't sound right to me anyway. Let's do it again. 9 times 30, that's 270. And 9 times 5 is 45. And what do you get there? You get 315. Well, what times 45 would be 315? That's going to be, let's see, 2, 4, 6. Let me see, 315 I said, right? Well, I'm getting tired. It's 7. So 7, all right, 7 times 45. So I got to do 7 times 34 now. That's 210, and 7 times 4 is 28. When you get over there, you get down 238. Plus, boy, what times 35? It's 9, and that's going to be 27 now. All right, let me get my eraser. I get a little distracted by this stuff over here. And what do you get? 27 and 238. And that's going to be, well, 8 and 7 is 15. Carry the 1. That's going to give me 4, 5, 6, and 265. So I'll write that down, 265 over 315. Let me get my eraser out again. I got some more arithmetic to do, don't I? I can divide top and bottom by 5. I'll write that down for you. 265, that would be 5, 25, you get 1, 5, 3. So 53. And I'm going to divide 5 into 315. What do you get there? 6. That's going to give you 30, and 15, that would give you 3. So what do you get over there? 63. Let's do the next one, multiplication problem. 5 times 4 is 20. 9 times 9 is 81. Not much I can do about that. This is going to be 8 ninths times 9 eighths. Well, 9s cancels, 8s cancel. You're left with 1 times 1, which is 1. Over here, I got the LCD. Let's go through that again. Erase this work over here. And I'll write down for you. It's 26, and 26 is 2 times 13. And the number 30, I'm going to say is 2 times 15. So what's the LCD going to be? Well, it's going to be 2 times 13 times 15. I'm going to do this one a little differently. I'm going to say 2 times 13 times 15. We'll do it as we need, by the way. And then I'm looking at the 26. What times that would be the LCD? Well, I'm looking at it, and I see 2 times 13 is 26. It's going to be 15. 15 times 7. I realize saying, why am I not doing arithmetic? There's a point to it. Now, I'm looking at the 30, and I'm looking at that, and I know that's going to be 13 times 30, and it's going to be 13 times 7. Well, I'm looking at this. It's still 2 times 13 times 15. Now, looking at the top, what do I notice? I notice it's, there's 7 15s. I'm sorry, there's 15 7s and 13 7s, which is 18 of them. I'm sorry, 28 of them. Sorry about that. All right, let me just go through that again with you. We're talking about how many 7s there are. There's 15 followed by 13, which is 28. All right? So I'm looking at this thing over here, and I'm wondering if there's any factors common between top and bottom to make my arithmetic easier. And there is. So what I see, 2 goes into 2 once, and it goes into 28 14 times. This becomes easier for me to deal with. 14 times 7 is going to be 70 and 28, which is 98. And 13 times 15, well, 10 times 15 is 150. And 3 times 15 is 45. So what do you get? 195. Right, let's keep moving along. What do you get over here? Oh, by the way, when I'm done with this, I'm going to grade this grade key, this thing, with using a calculator. I'll show you to do that. So I'm going to say the LCD looks pretty easy to me. It looks like 26. And what do you get there? We get 15 minus 4, which can be 11 over 26. What's over here? Let's write this down. 16 over 27 times 9 over 24. And I'm kind of looking at it. 9 goes into 9 once, 27 3 times. 8 goes into 24 3 times. And 8 goes into 16 2 times. We're left off with 2 ninths. All right, let's do the next one. Kind of running out of room. This is 120. All right, 120 is 120 over 1 times 12 over 5. And that's kind of nasty, isn't it? So I'm going to say 12 times 12 is, maybe I should write that down for you. It's really 12 times 12 times 10. This is 144, so you get 1440. Oh, you know what? Let me do the division first. I was just willy-nilly multiplying. But I noticed that 5 goes into 120. How many times? 24 times. Let's write that down. So it's going to be 24 times 12. Let me go through it again. 5 goes into 5 once, and it goes into 120 24 times. All right? 24 times 5 is 120. And then I'm going to still look at this, and I'm still looking at 12. So it's 2 times 12 times 12. And 2 times 12 times 12 is 144. So what are you going to get? 288. So the answer is 288 for that one. All right? Let's do this one over here. What do you get? 3/5 times 200 over 1. And 5 goes into 240 times. And 3 times 40 is 120. All right, put this one down. What do you get over here? It definitely more difficult, by the way. So we went to 24 down, and that's going to be 3 times 8. All right, but you can write it differently if you want. 21 is 3 times 7. So what's the LCD going to be? It's going to be 3 times 8 times 7. Well, I'm going to write that down. It's 3, 8, and a 7. All right? We'll multiply it out later, by the way. So 24 is 3 times 8, so I have a 7. So it's going to be 7 now. Plus, well, that's going to be plus 8 now. All right? And why is that? 3 times 7 is 21. I need an 8 there. So what do you get over here? 15 over 3 times 8 times 7. I'm going to reduce it by 3. 3 goes into 3 once, goes into this 5 times. So you get 5 over 56. All right, so the next one, a little less challenging. It's 24 LCD. That's going to be 19. And that's going to be 3 times 5, which is 15. We're left off 4 over 24, which can be 1 over 6. That's done. This one over here, it doesn't look that bad. It's 32. LCD is 32. So I'm going to say 18 because 2 times 16 is 18. 2 times 9, I'm sorry, 2 times 6 is 16 is 32. 2 times 9 is 18 minus 13. 18 minus 13 is 5. So you get 5 over 32. All right, let's put the next one down. And that's going to be 15 fourteenths times 28 over 3. And this looks pretty easy. 14 goes into 14 once, into 28 2 times. 3 goes into 3 once, and it goes into 15 5 times. And 5 times 2 is 10. Let's put this one down. Again, I'm kind of running out of room here, so I'll put it over here. I'm also going to get my eraser out to get rid of my LCD work. I don't need that. And again, it's sort of like, whoops, I went too far there, didn't I? And I got to get my eraser out again. I meant to erase this, not the other guy, because I'm going to check this with the K. So I just forgot what I was doing. Oh, this is 10. Sorry about that. I just forgot what I was doing. I was going to put this one over here. And what's it going to be? 5 over 1 minus 7/4. What's the LCD? 4. And what do you get there? You get 20 minus 7, which is 13/4. All right? Let's put this one down. I'm looking at it. I notice kind of immediately, 9 goes into 9 once, 27 3 times. And 7 goes into 7 once, and 28 4 times. We're left with 1, and the bottom you're left with 12. All right, this one, 101, it's 19 over 95. And let's go for that. And let's write it down. So I'm going to say 19, there's not much I can do as a prime number. I'm going to say 19 times 5. And why is that? 19 times 5 is 95. It's going to give you 50 and 45, which is 95. What happens? There's a cancellation over here, and you get 1/5. All right? So I'm going to claim over here, it's not a pleasant thing to go through, but you really need to learn to do fractions. I'm also going to say that when I go back over this, you're going to see me do it with a computer algebra system, and that is a calculator. I'm gonna go through all those problems calculator. Now granted, I haven't watched the video, but if you want, I'll provide a link to a video where this guy's going through all 100 fractions, all right? You might have something else to say about it that you might find entertaining or useful. All right, thank you, but you should be able to handle fractions. Thank you.